All right, it's page 4 of section 1 in chapter 11. We talked about two types of frequency distributions, grouped and categorical. We're going to do on this page for a categorical example. The data can be partitioned among several categories or classes by listing the categories along with the number or frequency of the data values. Okay. So, for example, a local coffee shop keeps a tally of types of drinks that their customers order each hour. Below is the following data from 49 drinks sold the hour before closing on a recent Tuesday. So, clearly it's a sample. All drinks sold an hour before closing on Tuesday. Now it says all. So I guess someone could say that that's a population of the last hour on Tuesday. But really, if you think about it logically, really the population is all the drinks sold at the coffee shop. Okay. So what their purpose is to sample the drinks sold at the coffee shop. So they're going to do a sample by using the hour before closing on Tuesday. So they might do another sample for opening on Sunday or the middle of the day, or they'll have different samples and they'll all have different averages, different frequencies. But we're not counting all of the drinks sold. That would be too many to count. If they sold 49 in the last hour, that would be ridiculous number crunching. They don't want to do all that. So they're going to pick a sample and go with that. Okay. So we want to start using our variables a little bit. The data collected. X is going to represent each item or data value written on the list. Okay. I got my clipboard. We're writing down one drink sold, soda, drink sold, espresso, coffee. I'm writing it down on my clipboard. Okay. And what I'm going to be writing down is the type of drink. So this is a word, okay, not a number that we can do any kind of measurements on. So it's not grouped frequency distribution. It's a categorical, okay? And then the N is the total number of data points on my clipboard, 49, okay? So here is my clipboard here, metaphorically, with the 49 different drinks that were sold. Okay, so I got my clipboard full of data. What do I want to do with it? I certainly want to start making sense of it. I want to start making a list of how many different things I sold. Apparently, I only sold 4 different kinds of things. So like all the coffee except an espresso fell under that category. Any kind of soda, any kind of tea. This is a predetermined type of drink label that they wanted to be able to keep track of, okay, for supply reasons, whatever reasons, okay. What sells the most in the last hour on Tuesday is a helpful thing. So what we're going to do is we're going to go through and keep a tally. So let's see, coffee, tea, espresso, coffee, espresso, coffee, espresso, coffee, tea, espresso, soda, tea, espresso. When I get to 5, I do that. Coffee, tea, espresso, coffee. So coffee's in the lead. Espresso following close behind. Oop. Somebody wants to stay awake. Okay. So 5, 10, 15, 16 is our frequency of the coffee was ordered. Let me double check my number of espressos. Oh, look, this doesn't have a cross out. Y'all probably saw that. 20. That's, I have to cross them out. I will mess it up. If I can go through and kind of go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I'm pretty happy with that number. So however you want to do this, there are tally spots in the homework. But whatever it takes to get these numbers absolutely correct, because you're going to do a lot of other things with them. So your frequencies have to be accurate, whether you're doing grouped or categorical. It's very important. All right. So to double check, I was supposed to have how many? 49. So 19, carry the 1, 49. Okay. So always check that total number. N is the total number of data points you should have up here, remember? Okay. All right. So once you have that, we're not going to throw numbers at people. We want to summarize for them. We want a probability of someone on the last hour and before closing on Tuesday of ordering a coffee, or at least a relative frequency, okay, which is the same thing. So remember, probabilities have N on the bottom and how many you had on top for the frequency. That's going to be 0.3265, so approximately 33%. Okay. 20. Around 41%, so more espressos. Sodas, maybe it's not worth carrying, or certainly carry far fewer amounts, around 8%. Remember, we're moving the decimal place 2, and I'm currently choosing to round to nearest whole percent. Okay, and I rounded all those, but these, if I did the math right, should come out to approximately 100%. If you're adding these, they should come out to approximately a 1. These should be approximately 100%. So let me add up 33 plus 41 plus 8 plus 18 is 100. So I must have not messed up my math. Okay. This tells you much more. So if I was telling my employees what to stock for a Tuesday evening, so don't bring a ton of soda. Tea is like half, but these are popular items. Be prepared to keep supply of those handy, right? So what I'm just saying just now would be inferential statistics. These numbers here are descriptive statistics, right? Statistics, by definition, is the results that you get from a sample summation, okay? And the inferential statistics is the stuff I just said about stocking. Given these numbers, what does that infer about the future? What should I do? What are people liking and not liking? These are the other things that I'm saying about that, and that would be inferential. Okay.